And we are live. So probably we want to give a few minutes before we, get started because people are starting to
Mhm.
join in the different platforms. So if you're watching this on X, on YouTube, and or on LinkedIn, we deeply appreciate your time. We promise you it's going to be fun and you're going to learn some interesting things about Flare Network. As a reminder, Flare is a layer one blockchain solution. I remember when I joined Flare, a lot of people were asking me if Flare was like an oracle, right? And this is a typical confusion that takes place, Oria, because we do highlight the fact that we have enshrined oracles. And of course, this is going to be one of the topics that we're going to be discussing today. But before diving into all of these interesting topics, I wanted to touch base with you, Oria. How are you doing today?
Yeah, doing pretty well. Pretty well. Enjoying a bit of sunshine in London. No, it doesn't last too long.
Doesn't last too long, but it's not too bad, right?
Yeah.
Okay. I guess that to provide a little bit more of context, because as I was saying before we start the live stream, I think a lot of people consider you a very smart guy inside the team, right? Inside Flare. But I'm not sure if people outside in the broader community are aware of the work that you do at Flare Network, which I think is extremely valuable. And this is actually one of the main motivations why I wanted to have this space. So let's start perhaps with a brief introduction on your background, what is it that you do, and perhaps how your day to day looks like at Flare.
Uh, yeah, so my background it's actually not related to blockchains at all.
Mhm.
Um, I've studied mathematical and theoretical physics. That's where I got my master's degree and my PhD. So I come from a highly theoretical space. We were doing string theory and algebraic geometry. And then I decided to leave academia, and someone reached out to me and said, "Oh, are you interested in cryptography?" So I had a lot of experience with elliptic curves, and I said, "Yeah, sure, let's give it a go." And I mean, that's how I ended up at Flare. But when I go here, I realized, wait, I actually own some XRP from back in 2020 or whenever. And somehow I got an airdrop for Flare, so I did have some FLR in my account, but wasn't aware. Um, yeah, so I joined the Flare, and then started learning about the project, integrating, and do my best to help. And yeah, you asked me about my day to day and what do I do. This varies a lot. I'm part of the research team. It really depends on what the needs of the rest of the team are. So sometimes the research can just be analytics and insights into the network, uh, things that we can try and improve, changing parameters, and also all sort of things like this. Otherwise, they could be the classic academic research, where we look. For instance, we had this project last year with machine learning, and we've been trying to combine blockchains and machine learning into something that we thought would be interesting and useful. Yeah, so it varies a lot. Depends when you ask me.
Right, that makes sense because the nature of research, I can imagine like in a startup environment and in general, now that we have AI, it's something that is quite dynamic, right? So it's interesting to know really where to put your energy and your focus, right? And I think that at
Mhm.
Flare, we do a good job at really going and diving deep into subjects. I do feel like at some time we need to start pushing more outside, right? So that people
Mhm.
see kind of the internal work that we do. But of course, having you on this live stream is just an amazing opportunity to pick up your brain and dive deeper into, some of these topics and your work as well. So I see that now checking across platforms, we do have a couple hundred across multiple channels. Thank you so much for joining. Like I mentioned before, today we're going to be diving deep into the blockchain aspects, of course, of Flirt. And we have Oria with us. Like I mentioned before, he's quite an expert on all of these topics. And so perhaps we want to start with the most basic stuff, which is explaining what a blockchain is. Um, yeah, and let's try to make it so that everybody can understand.
Yeah, very very good question. I have family and friends who know nothing about the space, and they ask me all the time. And I think my favorite analogy is to start from like a simple Excel table or spreadsheet, and everyone knows what that is. Everyone knows how it looks like. Um, and so you want to add in your Excel, you want to add new rows. That is the equivalent of what a block is in the blockchain terminology. So a row, let's just call it for now a block. You add as many rows as you have, as you want. These would be new blocks into your database. Um, but the problem with the Excel database is that there is a single owner, and that owner can edit it at any point, and however they want. So you can go in the middle of your database, subtract a row, no one will ever notice, and you are perfectly fine with that. Now the blockchain itself, so it is an immutable database, meaning that you can't really change it that simple. And instead of having a single owner, there is a whole network of independent participants who keep a copy of this database. And then if you want to make a change, then everyone across this network needs to agree on that change before you can actually make it. So adding a row in the database, adding a new block is no longer possible unless, it's no longer possible from a single person. Instead, you need to talk to everyone else. You need to let them know that you want to add a new row. And that's how, if everyone agrees, that's how you will eventually do it. But after you added this, you can no longer make any edits because each new row cryptographically references the previous ones. So if I give you the previous example where I go in the middle of the database, I delete one row, which is the block, and then I pretend like nothing happened. Well, from that block onwards that I deleted, all these cryptographic references are going to change. So it's going to be immediately very easy to see that something is missing.
Got it. So I think we at some point we need to, like, this was a great way to put it, and but to explain this to my mom, I don't know if she's gonna understand about these cryptographic proofs and all of that. So I think I would start with the ledger and spreadsheet, and try to simplify it from there. But it was an amazing explanation, and in regards to that, I'm wondering how you would introduce Flare Network, right? And you also mentioned security, and this is one of the core things when it comes to blockchain design. And the question in that regard would be, what are the core security assumptions of Flare as a blockchain?
Just to touch base on your second to last question. So regarding the network, indeed, this is probably something like a concept that is a bit hard to grasp when you come into contact with blockchain. So there is not like a single server where something is running, and that's the blockchain itself. That's how we used to think, because that's how internet works. There is a Google or some other giants that host most of the stuff, and you interact with this one thing. With the blockchain, you have multiple entities, each holding a copy of the blockchain, and then they verify independently that things are working well, and have to come to agreement for any new blocks. So you asked about the core security assumptions for Flare. So Flare itself, we call it an Oracle network. And perhaps following up on the previous analogy that I gave, blockchains are closed systems, meaning that they do not know what happens outside of this database unless someone from outside brings such events onto the system. So if you're looking at price, if you're looking of tweets from Elon Musk or anything like this, such information will not be in your database unless someone brings it explicitly on chain. And Flare is a blockchain that is specifically designed to bring this data on chain in a trust minimized way. And I mean, the use case here is we can talk about this later. It's evident through its EVM capabilities, but the key question is that we're trying to answer is if someone brings certain data to the blockchain, can I trust that data? And instead of relying just on a single individual, on Flare, all this data is provided in through a decentralized mechanism, which is the same mechanism that secures the blockchain. So all these people that participate in validating, in approving every single transaction, every new block, they are also the ones that agree on the data and bring the data on chain.
So I would say this is a sort of key difference in regards to the design of other L1 blockchains, isn't it?
Mhm.
Yeah, cool. Do you have something to add to this?
Yeah. So I was gonna just start this sort of thing. Indeed, Flare is designed with the Oracle properties in mind, but these are built on top of the actual L1 blockchain.
Exactly. Yeah. Okay. Before we move forward, I'm checking here the different social media platforms. People are saying hi from LinkedIn, also from YouTube. We have some people not being able to have a proper sound. Please do check your devices, guys, because we don't have any other issue on our end. I'm also checking on X. We have quite a few people there. And we will have some questions that you can ask, and of course we will try our best to reply, of course related to Flare and the topic in discussion today. So make sure you stay tuned, make sure you share this with others, and let's move forward now. The next question that I have is about transaction finality. This is a concept that I always see, developers kind of struggle to understand. So maybe we can explain this from the fundamentals first, and then how does it work on Flare?
Yeah. So I think here people are okay. So to clarify first, the question refers to how long you actually need to wait before considering that a transaction is safe to use or to rely on Flare. You made the swap. How many blocks shall you wait before thinking that okay, that swap has happened, nothing is going to change anymore? And this probably goes back to Bitcoin, where there's this famous 6 blocks that people know. And on Bitcoin, you make a transaction and you think that after 6 blocks, things are safe and you can proceed further. But even there, this 6 block window is actually not a deterministic guarantee; it's just probabilistic. So it can still happen that your transaction would be reverted even after the 6 blocks, but it's just not very likely. In any case, going back to Flare, on Flare things are much simpler. And to put it very simply, finality is immediate. So Flare relies on Avalanche. Flare started as a fork of Avalanche, and is using the so-called Snowman++ consensus protocol. And within this protocol, there is no notion of a fork. So once a block is accepted, once the honest validators have agreed that the block is fine, no issues with it, and considered it accepted, and it's adding to the chain of blocks, to the blockchain itself, then there is no concept of reworking. You don't need to wait for more confirmations. Once the block is done, is accepted, then that's it. The validator code itself does not have a way to create any new forks. And maybe let me tell you. So going back to Bitcoin, the problem there, the cause of the root cause of the issue is that sometimes there are times when multiple miners find a new block at the same time, and then the question is, okay, which route do I go through? And you wait until one of the paths, one of the branches becomes slightly longer than the other, and then you pick the longest one. On Flare, as on Avalanche, the block proposing mechanism is very different. So first of all, it works in slots, where from the validator set, there's initially just a single validator selected to propose a block, and only if this validator hasn't proposed anything in its selected slot, then others can come up and then propose blocks. So it's always one block at a time. And because of this, it very rarely happens that you even have two blocks proposed at the same time. So that would need, that someone proposes towards the end of their slot, and then another guy is fast and proposes blocking in the immediate next slot. But yeah, the consensus mechanism is designed to deal with such cases, and if that happens, only one of those blocks would get finalized, and that's immediately considered final.
Okay, so here I want to expand a little bit more because this is a very interesting topic. So you mentioned, for instance, that Flare uses Avalanche consensus, right?
Yeah.
Also, I'm not entirely sure people in our audience, they understand what is a consensus and what are like kind of the other pieces around, right? Like we're talking about a blockchain, we talk about oracles. Now we're talking about consensus. Perhaps we should try to clarify what are all the different components on a blockchain, and what is the role of the consensus, and also perhaps discuss also potential failures in consensus, and how does that work?
Mm-hmm. So what a consensus protocol is, we start, okay, on a blockchain, we have this network of entities that validate the network. Let's call them validators. Yeah. And the validators don't have immediately like a centralized means of communication. There is no central server to which they send messages and they await replies. So instead, let's say the two of us are all validators among others. I don't know, unless I contact you personally, I don't know if you consider a block to be good. Or if you have some other preferences, you think that a slightly different block with slightly different ordering of transactions would be better. So because of that, I need to reach out to as many people in the network and ask them about their preferences. And the complication is that all these preferences can change. So I have to do this repeatedly. And the simplest way back in the probably 90s or even earlier, there were these PBFT type protocols, where essentially you'd have everyone in the network asking everyone else in the network multiple times what their preferences are. And then, after multiple rounds of doing this with a lot of redundancy, you'd think, okay, everyone is on the same page. Let's finalize this block. There have been a lot of developments since then, and the Snow family, designed by the Java Labs guys, are a family of protocols that are different than the classic PBFT, and much more scalable. So instead of having this communication complexity where you actually have to ask everyone else multiple times, you only sample the network a bunch of times, and this sampling turns out to be enough and much faster than in this brute force scenario that I mentioned. In terms of failures, so when we talk about consensus protocols, we usually look at two things, and these are safety and liveness. So for safety, we don't want that two nodes that are well behaving, we don't want those to end up accepting conflicting blocks. By conflicting here, I mean that they have maybe the same block number, but the transactions inside the blocks would be completely different, or just a tiny bit different. That's safety. And then liveness means that we want the system to eventually continue producing new blocks and that it does reach new decisions. We've been running extensive tests of various types of attacks. There's a lot of both theoretical simulation and practical tests that you can come up with and see how the consensus protocol would behave. But basically, across all these tests, Snowman++, which is our consensus protocol, has very strong safety guarantees, which means that as long as the protocol's assumptions are satisfied, so you have a certain number of up to a certain number of adversarial validators in your validator set, then all the honest nodes will converge on a single preference, on a single block. There will be no conflicts. And yeah, anything that's conflicting will not be finalized. But what can happen is that this convergence can turn out to be a bit slow if there's a lot of adversaries, or if there is some significant adversarial pressure in the network, which will have an impact, of course, in the latency or the liveness. But this is the trade-off. You want to make sure that you reach a single decision, you don't create a fork, and to make sure that this happens, you give away some latency.
Gotcha. I'm thinking about this. This is a very interesting topic because also when you mention, for instance, security, it reminds me that in this industry, in crypto, we often talk about security, and sometimes we are talking about cryptographic security, right? Secured by math, let's say. But we are also talking about, in a lot of situations, we're talking about economic security, right? So could we explain a little bit more what is economic security and how does this apply? I think you already mentioned a little bit about consensus and when it comes to block validation and at the protocol level as well.
Yeah, great question. So in principle, all these protocols, they start up as some theoretical design. They have theoretical guarantees, and everything works fine in theory. But then when you start implementing it, there is a lot of other factors to take into account. And you'd say, okay, you need the control of half of the validator set. And here's where the question that you posed comes up into. Is it economically rational for me to try and attack a system, so to make some profit from attacking the system? And this is what we mean by economic security here. If the decision is not economically rational, then I won't proceed with this attack. Flare itself is a proof of stake blockchain. So every validator in the validator set needs to have at least a 1 million FLR self bond, and this self bond needs to be staked there for at least 2 months. So there is some incentive, for validators to behave well, because if something were to happen to the network, that would most likely impact the price of the FLR, and then whatever they have staked there and is locked will just depreciate in value. Okay, but that's 1 million is what a validator has to do, like at the bare minimum. If you look at the total amount that's staked, I looked a couple of days ago, and I think it's around 11 billion FLR, which is, I don't know, $120 million or something like this. So if you really want to get control over the network to decide whatever goes into the block, then you need control over a significant portion of this. And unless you have some very rich friends, then this is probably quite hard to do in practice, and you'd look at other ways to do it. But this layer this is what economic security here. We add another layer of security on top of the already stronger theoretical guarantees that we have from the consensus protocol itself.
Right. And here to expand a little bit on perhaps how users contribute to the security of the network. This is done because of course you mentioned here there is a security budget, so to speak, tied to the amount of FLR that is staked. Is that correct?
Indeed, yes. So there's two ways that users contribute. If we talk strictly about the network itself, so we forget about the core protocols, then this would be just staking. I said that Flare is a proof of stake. Flare is actually a delegated proof of stake chain, meaning that if you want to stake some tokens, you don't necessarily need to run up a new validator entity, which means something that runs a software. You don't need to run that software. Instead, you pick someone who's already running a node, and you delegate your stake to these guys, which means that your stake will be locked for, I think the minimum is 2 weeks. Your stake will be locked to that validator, and whatever rewards that this validator is earning, then a share of that is also going to you. Yeah, but essentially this is some sort of a transfer of vote power. Wherever that stake is used, which is, for instance, the block proposing mechanism. So the larger stake you have, then the more often you'll be selected to propose blocks. So if you have more stake, you can get more stake by having people delegate the stake to you, or by putting yourself additional stake into the system.
And there are rewards, so there are incentives for everyone to just go and stake more and contribute to the security of the network and earn rewards. So it's a whole system that is, I would say, sustainable from that point of view, right?
Indeed, yeah. So the rewarding system nowadays has become very complex, and perhaps this is one thing that some people are not aware of. It's no longer enough to simply pick a validator that has good uptime and delegate your tokens to that validator. The problem is that that validator needs to also contribute to the data protocols, the oracles. And this was introduced in Flare Improvement Proposal number 10, I think. We call it minimal participation requirements or minimal conditions. So if an entity, an infrastructure provider, and their delegators want to earn rewards, then the infrastructure provider needs to have good uptime in validating services. They need to submit prices to the Flare time series oracle, and they also need to verify attestation requests in the Flare data connector. And there is different thresholds everywhere.
Just to clarify, they cannot skip that. They have to. Okay.
If they skip one of those, they will essentially lose all the rewards across all the other protocols. So if you don't have a good enough participation in the Flare data connector, then you might lose all your rewards from the FTSO and staking services.
Right. And in connection to all of this, since we're talking about economic security and we're talking about, Flare data protocols, just want to clarify if economic security for block validation and Flare's native protocols are the same thing or not, and what's the difference if so?
Yeah, very, very good, very good. So Let me first say that okay, we have. I already mentioned the one way that community users can contribute, which is through delegating stake. But then they can also delegate wrapped FLR tokens, which is a bit of a lighter action. You can always undelegate your tokens. This is done. I mean, you pick your provider, you delegate to them, and the process is much simpler. While with delegating stake, you actually have to wait for that at least 2 week period to unlock your funds. Now, while in block validation, economic security is just solely determined by these staked FLR tokens, for the rest of the protocols, so the FTSO and the FDC, the picture is broader. Now, with that FIP that I mentioned, which effectively links all the protocols together, we said that we achieved better enshrinement. Yeah, because now the stakers, the ones that validate the network, are forced to actively participate into our oracles as well, and that's why we call them enshrined oracles. But apart from the stake itself, the amount of wrapped FLR delegated to data providers is also taken into account as towards the vote power of an infrastructure entity. So basically, you can have situations where someone has a lot of stake, but maybe not that much wrapped FLR delegations, or someone has a lot of wrapped FLR delegations, but not that much stake. And these guys could actually be on equal footing inside the protocol because their vote powers are similar. There are some nuances here, but yeah, roughly speaking, the data protocols are the economic security of the data protocols is different because you have two factors here that contribute: the
Right.
stake delegations and the wrapped FLR delegations.
So there are two ingredients there. Okay, thanks for clarifying that. I think that a lot of people are actually not aware of this. People are actually commenting on YouTube, very interesting, and on X as well. So I invite you. We're gonna change a little bit the subject here in a few seconds, but I invite everyone who's watching this to share it with others so that we can get more people into the room. And if you have any questions, please feel free to put those on the chat on the live stream on YouTube. The same goes for X as well. And actually, you can go to the Flare Dev account and ask your questions there. I'm constantly monitoring this so we can get some nice community questions. Now, let's talk about a node. This is a concept that I think people or or perhaps Web2 developers, when they are just getting started to build on any blockchain, they get confused about, and also the concept of a state sync node, right? There are some subtleties there that I think are worth, explaining.
Yeah. State sync is quite a relatively new thing, but okay, let's start with a node. And I think I would simply put it that a node is, roughly speaking, just a computer or a server that is running the blockchain software. That is, all you have to do here is clone the GoFlare repository and run. Well, you don't even have to just run a Docker image, but that's pretty much what's happening. And when you run this, you are effectively participating in the network. You no longer have like a passive role. So what this node does, it stores a copy of the blockchain, or rather the blockchain state. It verifies block transactions and that everything is following the protocol rules. And then it communicates with other nodes. So from the perspective of network roles, you can group nodes in two categories. You can have validator nodes, which are the nodes that are publicly visible to all the participants in the networks. You need to expose some additional ports because these validator nodes are the ones that they propose blocks. They are the only ones that can propose blocks and thus participate directly in the consensus protocol. And then you also have observer nodes, which are usually used for just transmitting events throughout the network. So you want to make a transaction, you can simply tell your observer node that you want to do this transaction, and then the node will communicate to the rest of the network. And you can also use this observer node from pulling out information. So the role of observer node is a bit more passive, but the code is the same, more or less. Now you asked me about state sync. Yeah. So back in the day, and then people that have been around for a while know the pain of this. If you wanted to run a node, you'd basically have to get the full history of the blockchain, which nowadays is order of terabytes. On Songbird, it's even worse because the blocks are faster, so there's a lot more of them there, and it would take, I think, maybe around 2 weeks or so. You'd have this server running, and then after 2 weeks, the block would finally get healthy, and sometimes you'd get this database corruption out of nowhere, and the node would go offline, and you have to start all over again. Fun times. But nowadays we have state sync. And state sync, effectively what it lets you do, it lets you get a node up in maybe up like 1 to 2 hours. That's how long it usually takes from scratch. And what it does, it's only picking up a snapshot of a recent state. And then instead of downloading the full history of the blockchain, you're only downloading whatever you need to construct that state.
It's much more efficient.
Yes, not to construct it, but to validate this this state. So you're looking at account balances, maybe the state of some contracts, and so on. The one downside is that if you query a node that's state synced and you ask for information for like a transaction that happened in a earlier block, they might not have it, so you won't get a response. But if you need some quick things, then you run this for a couple of hours, it gets up, and yeah, quite a light client as well.
Yeah, so it all depends at the end of the day on what is the main purpose that you want to serve, right? When it comes to running nodes. Okay, let's talk about something that for me it's very interesting, which is like the journey of a transaction. Because from a user perspective, you have your wallet and you can send money everywhere in seconds, and it looks like kind of magic, right? And we have discussed about like different aspects of the blockchain with consensus nodes and whatnot. So I think it's a good time to go over what really happens when you send a transaction on Fleur specifically, and if there is a mempool, and the whole journey.
Yeah. Okay, so everyone that has a wallet essentially has a pair of public and private keys, which are used to make sure that no one else can replicate your transactions, but they can still verify them. So you'd never want to expose your private keys, because that would mean that others can sign in your place. So what happens when you create a transaction is that you locally sign with your private keys, and then you send this transaction to a node. Let's say to an observer node because that's what you usually do. Next up, this observer node, so it picks up your transaction and it just perform some basic checks. It checks if the signature is valid. It checks if the format of the transaction is valid. It checks if the gas limits and the fees are well formed. And it also checks that the account you're sending from has enough fees to pay for gas and for whatever else if it's a token transfer. And yeah, a bunch of simple rules of the sort. If all these pass, then the node, this observer node that you used, will add this transaction to their mempool, and then they will further send it to all the nodes in the validator set. Because ultimately, these guys, the validator nodes, are the ones that are creating the blocks. So the transaction reaches, let's say the transaction reaches the validator nodes, and then one of these nodes is finally selected to propose a block. They look at their list of transactions, the so-called mempool, and see your transaction there. They take it, they put it in a new block. They order a bunch of transactions in this new block, and then after this block is formed, they first execute the block. So on Flare, it's first execution, and then the block is sent further to all the other validator nodes. Actually, it's more than the validators. The block is also sent to non-validators, to observer nodes. But okay, so here is where we start applying the consensus protocol. So the transaction is in the block. The block is now being broadcasted to everyone else, and people start seeing the block. They also execute the block. They check that everything is looking fine. They try to apply the transactions in order first and execute the smart contracts themselves as well, and updating any balances and state. But if all this part is finished, then you go through the actual gossiping part, which is this Snowman++ protocol that I also alluded to earlier. And only at the end of following all these steps in this protocol, if the block becomes finalized, only then you can say, yes, we can now finally accept the block, which means that we can update all the account balances, the state, the blockchain state, and everything else as we've already executed the block. So we know how to make these updates. We only do it after the block goes through the Snowman++ protocol.
Okay. And that's it.
And yeah, that's basically it. And then, since this was the first, or one of the first questions, that transaction is finalized. You can't revert it anymore.
Exactly. Okay, that was cool. At some point you mentioned, of course, about having some order and blocks that are produced and whatnot. So I think that it's a good moment to talk about the concept of MEV. And actually, I would like to pick up your brain and learn more about, your opinion on MEV and how does this plays out when it comes to incentive alignment.
Yeah, so MEV really just stands for maximal extractable value. And this has been a very big issue on many networks because at a high level, this extra value comes from transaction ordering, as you've already mentioned. So basically, we have this situation where transactions temporarily sit in a mempool. Yeah, and if a validator or whoever is selected to build a block has the ability to choose which transactions go first or which transactions go at all into the block, then they can pick some transactions for whatever reasons before your transaction. So to give you some example, let's say I'm thinking of swapping a large amount of FLR into FXRP or something like this. This will have an effect on the price of the two assets. Yeah. So if a validator notices my transaction in their mempool, then they can decide to first front run my transaction. So they buy, they first place a buy order on the token I'm swapping into. Then they get my transaction as a second transaction. And after that, they come with a sandwiching transaction where they sell their position and get whatever profits. So basically, they're using the fact that I have a large transaction and I cause a change in the price to make a profit, to place a first initial transaction that gets them a position onto the token, and then they sell their position afterwards. MEV exists on Flare as well, but here really the only thing that I would like to mention is that the validator set itself has some advantages over the non-validators. So all these transactions in the mempools are not really readily or easily accessible to the observer nodes. If you send a transaction to an observer node, then this is not really going to any of the other observer nodes until the transactions appears into a block. So if you wanted to do some MEV stuff, then you'd either just watch transactions and have a bit of delay. You see the transaction appearing into a block, or you'd try to collude with some validators, so some nodes that have a stake, and then you'd have some easier access into the mempools.
Right. So bottom line, at least on Flare, you cannot say that we make it easy for MEV extraction, right?
Yeah. So there is no Flare specific mechanism here that we have against MEV. These were the whatever designs were implemented by Avalanche, which also had some issues with MEV, and there were some patches that they pushed a while ago. But yeah, basically, nowadays you need to have access to some validator nodes, otherwise it's a bit trickier to do it.
Amazing. I think this was super insightful. And you know what? At some point, I was thinking about when we were discussing the concept of nodes and whatnot. And I'm wondering, perhaps we should also clarify what an RPC is, and perhaps some of the most like common misconceptions around RPCs that developers might have, because I think that at some point people can get confused between RPCs and node and the role that each one plays.
Yes. So an RPC is simply put just an interface that lets external applications talk to the blockchain, and it's basically how you'd submit transactions, how you'd read balances or contract states, how you'd pull any data from the blockchains. The RPC node itself won't decide the exact contents of a block because that's strictly limited to the validator sets, and will not finalize the transactions themselves because this is again an operation that the validator nodes do. But it just answers questions and then the relays requests. In terms of misconceptions, I would say people probably don't know how light an RPC node is actually now with state sync. And I think a lot of people think that it's heavy, it's expensive, and it's the same as a full history validator node.
Yeah.
In reality, you probably only need something like 20, 30 gigabytes of disk space, maybe 2 gigabytes of RAM, and just very little CPU. And yeah, with state sync, you get it up in a couple of hours. And the bottleneck here isn't computation, isn't the node itself, but whatever requests you are making. So the node itself is not heavy, but if you put a lot of load onto it, and some of the ETH methods are quite heavy, then that's when you'll actually have issues with the node.
Right. So we have, I think, two more questions from my end, and then we're gonna move forward and go ahead with some of the questions from the audience. I'm seeing a lot of questions in regard to protocol managed wallets and TEs. And I'm seeing a lot of questions in regard to XRP staking. How does that work? And the connection to FLR and all that. So I think
Mm-hmm.
probably those are the main two things that we can cover at some point, Oria.
Mm-hmm.
I know that we created this space for 1 hour, and I think we might have to extend 10 more minutes if that's okay for you.
Yeah, yeah, that's
Um,
fine.
Cool. So let's move forward. I wanted to touch base on F assets. Why? Because I think we have over the years, we have discussed a lot about what makes Flare unique in terms of the Flare data protocols, the FT software price feeds, and the FTC for Web2 data verification.
Mm-hmm.
But what makes like the F asset system unique in terms of like a bridge? I think that people perhaps they have heard that it's an over collateralized bridge and that's it. But if you compare like the F asset as a system, as a bridge, in comparison to what a traditional bridge is, or what you would expect from that definition,
Mm-hmm.
what would you say about this?
Um, so in traditional bridging, you'd have a user basically send assets to some bridge control address on the source chain, and then there would be some system, some off-chain system that watches these addresses, and when they see a deposit, they mint or release some representation of that token on the destination chain. And the core security of such bridges is usually that the bridge operator behaves honestly. And of course, there is many bridges between EVM chains. We have Stargate integrated on Flare, and here things are done much better nowadays because you rely on smart contracts for locking and minting funds, and also verifying some proofs that the funds were indeed locked or minted. But the design, I mean, this design, for instance, that I mentioned for Stargate and usually of bridges between EVM chains, they rely on smart contracts quite heavily. And Ephasis tries to go beyond that and to link non-smart chains to this already existing network of EVM blockchains.
Right,
Uh,
and
s-
I think that here, for data protocols play a significant role in the sense, for instance, of the FTC having this sort of multiple chain verification and whatnot, right?
Indeed, indeed. So if you take the facets design, it's a collateral based approach that indeed relies on the Flare data connector. So once you lock, say, some XRP on the XRP ledger to an agent's address, then you can attest on Flare mainnet that this transaction has occurred. And actually, before you locked your XRP, the agent itself has to lock some collateral on Flare. So even if somehow that agent decides, yeah, I'm just gonna run away with that XRP on XRP ledger that you locked, your funds will not be lost because you'll have an equivalent on Flare, and at worst case you just made a swap and then you can swap it back. And here the key is that the security assumptions go towards FTC, so towards a testing that the transaction has happened on XRP ledger in this case. And as I mentioned earlier, there you have the staked tokens and the wrapped FLR delegations, which contribute.
Right.
If you add them together, you're probably looking at, I don't know, 20, 30 billion FLR at least, that you'd need to get that 50% of the vote power. So to getting some false attestations through the FTC.
Right, right. So amazing. Thank you for clarifying that and highlighting the role of Flare data protocols in F-assets and
Mhm.
how it's different from other bridges. And for the people in our audience that are, normal users and they just want to use this, you can go to our portals to mint F-assets. Essentially, you would, like Ori explained it, you would log your XRP on Flare, then reserve collateral, and then you will have to mint your FXRP, which is this one-on-one representation of XRP, but on the EVM side, and then you can access to DeFi on Flare and even move it to other chains like Hyperliquid, Trade, do whatever you want, right? It's really an interesting design. So since we're right at the end, I want to take some of the community questions. Let's start with protocol managed wallets. What is this at a high level? How does this connect with the vision for F assets? And also, how is this connected with TEEs as well?
Mhm. Yeah, so protocol managed wallets is something that the Flare team is currently working on, and hopefully we'll see something live soon. But the idea is that so in F assets we had the agents that need to lock their collateral and help with minting and redeeming. Um, Now in the new design, which will be F assets v2, these agents will essentially be replaced by TEs, which will reduce any remaining trust assumptions. So the idea is that the operational role of the agents will be automatically executed inside these trusted execution environments. And the very useful thing about the trusted execution environments is that they are secure enclaves where if you decide to run some code, that as long as the TE is running, you can see, you can prove what is the code that is running inside there, but you cannot actually alter it. So you'll have guarantees at any point that what's happening there is what's supposed to be happening, and no one is playing around with any sort of funny business.
Right. So, bottom line, this would, give you more efficiency and more security.
Mhm.
Um, and I was thinking about how is this connected with the role of FLR, and I think that this is a good segue to actually talk about perhaps your perspective on the role of FLR in the ecosystem, and also to clarify what is even XRP staking. People on Ethereum, they know about the staking from a long time. People on the XRP layer, they're just learning about XRP staking. So perhaps it would be nice to have your perspective about around this and the role of FLR as well.
Yeah. So for the role of FLR, of course, the protocol managed wallets. So they're running TEs, but if you think about the underlying, if you think about the underlying data protocols that are being used, FDC here is still remains key, and FLR tokens are the ones that are powering and are securing our data oracles. So it's still very much at the heart of the network. Apart from the very simple transactional fee that you need to do, they play this key role that the data protocols are secured by FLR tokens. As for XRP staking, yeah, this is not staking in the classical sense, as we have FLR staking on Flare. But the idea here um, would uh, um, would be more or less that it acts like some sort of AVS, where you contribute with your XRP. There is a mechanism for earning rewards, and whoever decides to use the protocol is basically has some guarantees of security based on the amount of XRP that is staked. So the principles are sort of the same with classical staking, but the design, of course, is not in the same spirit, because we're not talking about securing a blockchain itself, but about securing some protocols.
Yeah, so there is a difference there, that I think people might need to take some time to digest and think about, and really think take a step back, right, and think about how FLR actually is like at the core of all these, like you mentioned, in terms of like the security of the network, of the data protocols that power
Mhm.
all of this. It just seems that maybe we have done a magnificent job at hiding FLR and the data protocols all as the underlying thing powering everything, right? And so then we get some people asking about this stuff. So I'm glad that we have this live stream and we could clarify this. Okay, I think we are right on time. And I think we have clarified most things, and we have had an amazing time discussing about how Flare uh, network works, actually. And is there anything you would like to highlight in terms of things that you have been doing research at that you find very interesting, or things that you're excited about that is coming to Flare, or anything along those lines?
Um, there's the systems are nowadays, they are in a very good place, but they are incredibly complex, and there's a lot of moving pieces. So I guess things that I'm generally excited about are quite nerdy, and people might not care that much, but there's like very little tweaks that we're looking at doing for basically for improving the experience of the users, and that they fly under the radar, but because of all these tons of moving pieces and a lot of different factors that you have to take into account, they are not that easy to tweak, but they are interesting mathematical problems.
Let's take one more minute to just dive a little bit deeper into this. Can we give one example of this? Because I'm 100% sure that nobody has any idea about it.
Yeah, I mean, gas fees, for instance, is something that we're currently looking at. So we currently on Avalanche 112, Avalanche 113 will come up with a new gas algorithm. So we want to make sure that this new algorithm is going to be good. It's going to improve what we have at the moment, and if we need to make any further tweaks to the current implementation.
So, thank you so much, Oria. I think we have covered all the questions. Let me just double check here to make sure I'm not leaving anything behind. Perhaps one final comment on Flare Smart accounts. What are your thoughts on this? Like, I'm seeing a lot of people um, that are happy because they will get the one-click experience they deserve on the XRP layer. But at
Yeah.
the same time, I'm seeing some people that are saying, "Oh, but where is FLR and all this? You're not using this as the token to pay for fees and whatnot." So perhaps clarifying that from a technical perspective would be helpful.
Um, I'll say that I'm afraid I'm not. I haven't really been involved with the Flare Smart contract, so I can't really comment too much in there. I'm, very roughly, I only know about the general idea, which to me sounds quite good. But yeah, as for the explicit tokenomics, I can't really add much
Oh
else to
yeah,
that.
yeah. Just meant about like the role of FLR in all of this, because at the end of the day, you can still argue that none of this can happen. For instance, if the FTC is not working properly, right? Because
Mhm.
when you send the payment instructions on the XRP layer, then you need to prove things on Flare as well.
Mhm.
And then you have the security assumption, for instance, for the FTC, and behind that, again, you would have FLR. So yeah, for the people that are not aware of this, I think is worth paying attention to it, not only to the implementation itself, which I think is going to become a main unlock for users, right? It's going to be the nicest user experience we have probably seen multi-chain when it comes to the XRP layer and any other chain, and you will get your yield and all of that. But at the same time, for people that are on the Flare ecosystem to understand that all of this is powered by Flare infrastructure, and that's powered by FLR. So thank you so much for taking this time today, Oria. Is there anything else you would like to add before we wrap this up?
Um, for all our devs, keep building, and yeah, for all our users, thank we are grateful for you being here, and yeah.
Amazing. Thank you so much, Oria. Keep securing the network for the users. That would be my personal call to action. Make sure you turn in your notifications as well for our social media pages. We have the Flare network page on X, and we also have the Flare Dev Hub that we're actually hosting this right now from this account on X. So congrats to everyone who's participating and supporting. And stay tuned. We probably will have more of these sessions. It was quite an interesting one. And thank you so much, Oria. I know you're quite busy and you're taking this time to teach us more about Flare. I think it's something that people really appreciate, and you can see that on the comments.
Yeah,
Thanks.
no worries. Thanks for inviting me.
All right, guys.